Hi students, today I am going to explain according to the hybridization theory how the molecules will be formed. So let's see first formation of Pcl5 molecule. So on the basis of hybridization theory, after that SF6 molecule and IF7 molecule. So it is very easy if we understand the hybridization theory. So in the first Pcl5 molecule, let's see, P is the center atom in the Pcl5 molecule. So phosphorus atom, its atomic number is 15. So we can write the electronic configuration like this: 1s2, 2s2, 2p6, 3s2 and 3p3. If we see the outermost cell 3p3, so 3px1, 3py1, 3pz1, because 3 are there. So 3 unpaired electrons are present. So the possible formation of molecule is PCl3, because P, it can share 3 unpaired electrons to form PCl3 molecule. So we can expect PCl3 molecule. So but it gets excited. It is in ground state, 3 unpaired electrons. When it gets excited, so after the excitation of a P atom, so what happens? The S molecule will lose its electron to the next one more P. So we'll get 3s1, 3px1, 3py1, 3pz1 and 3d1. So one pair of electron from S will go into the D. So we'll get 1, 2, 3, 4, 5 unpaired electrons, and here PCl5. So easily it can share its 5 electrons to the 5 chlorine atoms to form PCl5 molecules after excitation. So what type of bonds are forming here? We can say S with P, or P with P, or D with P. So 3 types of overlap is possible in this. So 3 types of overlap like SP, PP and DP is possible in this. But in PCl5 molecule, 2 types of bonds are observed. So it is explained by hybridization. What are the bonds? Let's see. So 1 3s, 3 3p. So 1 3s, 1 2 3 3 3p and 1 3d are possible. So we can write S p3d hybrid orbitals with 1 electron each. So like this, the hybridization we can write easily. So just remember how many S electrons? 1. 3p electrons and 1 d electrons. So sp3d hybridization is formed, and the sp3d hybrid orbitals are formed in this. These hybrid orbitals will have high energy than the excited p atom. So these atomic orbitals will have low energy than the hybrid orbitals. So after the hybrid orbitals are formed, it will have high energy. These 5 hybrid orbitals overlap with 3pz half-filled orbitals of chlorine. So that is why sp, pp, dp, because all the chlorine atoms which are interacting with the phosphorus will have pz half-filled orbitals. So there will be a formation of sp3d bonds with chlorine bonds. PCl bonds are sp, pp and dp bonds. So with all these 5 hybrid orbitals, it will give a trigonal bipyramidal structure. What is trigonal bipyramidal structure? Let's see. This is trigonal bipyramidal. Its drawing is very easy. Just we draw a triangle. So 3 sides will be attached, and 2 chlorine atoms on the axial ends, one above and one below, and the angle between them is we can see here 90 degrees. Here 90 degrees, and this is also 90, and between these two is 120 degrees. So sp3 hybridization, and axial bonds are slightly larger. These bonds are little larger than equatorial bonds, because axial bonds have greater repulsion than equatorial bonds. They will have more repulsion. So because there is an asymmetry in this structure, it is very reactive, or it is not a stable form. So it is an unstable molecule. So it splits whenever it is possible, because it is unstable. It splits into PCl4 plus or PCl6 minus PCl4 plus when it loses 1 electron, and when it gains 1 electron, PCl6 minus in solid states which have tetrahedral and octahedral structure. So PCl4 plus is tetrahedral structure and PCl6 minus is octahedral structure. Like this we can explain the PCl5 molecule. It's very easy. Just write the electronic configuration, after that in the ground state, after that excited state, and just see what are the overlaps are going on. According to that we can give the structure. Then next is SF6 molecules, sulfur. So the center atom is S sulfur. Its atomic number is 16. So we write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. Here the outermost shell is 3p4. So here 3px square, 3py1, 3pz1. So according to Pauli's exclusion principle and Hund's rule, the electrons are filled. We know first x, afterwards y, afterwards z, again x. So it is paired, so it will not take in the bond formation. Only 3py1, 3pz1, these are the unpaired electrons. It will take part in the bond formation. So two unpaired electrons are present, so we can expect SF2 molecule. But again it is in the ground state. Again it will go to excitation state. When it gets excited, then what happens? 3px2, it will give 1 to 3dz. So 3px1, 3py1, 3pz1, 3d1z square. So we'll get 1, 2, 3, 4 unpaired electrons. And again we can tell SF4 molecules, because 4 unpaired electrons. So SF4 molecule can be possible, only be possible. So then how SF6? So one more excitation takes place here. So S atoms come in second excitation state. So again this S will be shared to one more D. So 3s1, 3px1, 3py1, 3pz1, 3d1z square, 3d1x square minus y square. So 2, 3, 4, 5, 6 electrons unpaired are there. So and it is capable to form SF6 molecules. So here again three types of overlapping are there, sp, pp and dp. So but here all the bonds are identical because of the hybridation. And what is the type of hybridation? So 1s, so s, 3 p's, p3, 2 d's, d2. So sp3 d2 hybridization is possible. And as usual the hybrid orbitals will have high energy than the atomic orbitals of excited at the sulfur atom. So and they will form octahedral structure. So whenever 6 will come, octahedral structure is possible. So S4 like this, and 2 in the axial state. Angle between them is 90 degrees and bond lengths are all equal. So and it is a very stable molecule. Then next is IF7 molecule. Central atom is iodine. So its electronic configuration is krypton 5s2, 5px square, 5py square, 5z1. Only one unpaired electron is there. So it can form in the ground state IF molecule. But how to form IF7 molecule? It will undergo excitation for 3 times. As in the case of we see in the last SF6, 2 times it got excited state. Here it will go to excitation for 3 times and 7 unpaired electrons will be formed. So 5s1, 5px1, 5py1, 5pz1, 5d1xy, 5d1yz, 5d1xz. Like this 7 unpaired electrons are possible, are formed, and so IF7 molecule is possible here. And again 3 types of bonds are formed, or 3 types of overlapping is possible, like sp, pp and dp. So and here what is there? 1s, so s, 3p, sp3, 3d, sp3, d3 hybridization is possible. So they will get sp3, d3 hybrid orbitals are formed. As usual they have high energy than the excited atom. So the shape is pentagonal bipyramidal geometry. So axial bonds are slightly longer than the equatorial bonds. We can see here IF7 molecule. So we give pentagonal structure with a bipyramidal structure. So and this angles we can see 90 degrees, 72 degrees and this all 180. So like this we can easily describe the structure of IF7. Thank you.